All right, I'm going to use one of the classic definitions of derivative to find a numerical derivative, and my function is going to be f of x is equal to 6 minus x squared. And I'm going to pick a point on here. My point is going to be 1. So if I put 1 in here, I get 6 minus 1 squared, I get 5. So if I would graph this, here I have this graph. It's a parabola going down this way and a parabola going down this way. And I have this point 1 comma 5, which is approximately right here. And let me go get a palette. Pick red. There we go. And I'm going to have a tangent line that passes through that point. And that's my function, and that's what my line would look like. And if you recall, so right here, my c is 1 because it's my x value. This right here is c. All right. And so what that's going to look like is, if you recall the limit, oops, let's try that against the limit, as x approaches c of f of x minus f of c all over x minus c. That was my definition. And again, I use this one when I'm given a particular point. So I'm going to rewrite the limit as x approaches 1. Now f of x is 6 minus x squared minus f of 1, which I know it's 5. I'll be fixing that in a bit, over x minus 1. So now I've got the limit as x approaches 1 of 6 minus x squared minus 5 over x minus 1, which is equal to, and I'm going to write equals here, the limit as x approaches 1 of, well, 6 minus 5 is 1, so I have a minus 1 minus x squared all over x minus 1. Well, that's equal to the limit as x approaches 1. This is the product of two conjugates, one of which is 1 minus x, and the other is 1 plus x, all over x minus 1. Now, 1 plus x and x minus 1 do not simplify, but let's take a look at what this means. So I'm going to write that over here, 1 minus x over x minus 1. Well, if we think of some numbers like 1 minus 3 over 3 minus 1, I get negative 2 over 2. If I take 1 minus 7 over 7 minus 1, I get a negative 6 over 6, which is a negative 1. So these are opposites, and I should get a negative 1 as my answer. Another way to look at that is I can factor out a negative 1 from the top, and this would be a negative 1, because a negative 1 times a negative 1 is a positive 1, plus x, because a negative 1 times x is a minus x, over x minus 1. And again, these would simplify. So these are going to simplify, but rather than write a 1 there, I'm going to write a negative 1 on top. So now what I have is the limit as x approaches 1 of a negative 1 times 1 plus x. Now I can substitute 1 into here, and I'll have a negative 1 times 1 plus 1, which is 2, and I get a negative 2. So my derivative is a negative 2. The slope of my tangent line is a negative 2. The slope of this red line right here is a negative 2. The equation of this tangent line, which I'm going to write y sub t, is going to be a negative 2 times x minus 1 plus 5. This is what we call point slope form. And all I need is the slope and 1 point. And the slope is derived from the derivative.